Hello and welcome. This is a lecture review for the William Stallings Effective Cybersecurity First Edition book. Again, this is a lecture review using the material offered by the publisher Pearson VUE. All copyrights belong to them. This is for educational purposes only. Again, the textbook is Stallings Effective Cybersecurity, a guide to using best practices and standards, first edition, done through Pearson VUE Education, ISBN number 13 97801 3477 2806. So again, copyright belongs to the author and publisher. I am just doing lecture reviews on the PowerPoints for each of the individual chapters. So without further ado, let's go ahead and jump on in. Alright, Chapter 8 is about system development. More specifically, we're going to be looking at the System Development Lifecycle, SDLC, in the overall process of developing, implementing, and retiring information systems. Various SDLC models have been deployed to guide the processes involved, and some methods work better than others for specific types of projects. So we're going to examine several alternate models throughout this process. One of the more popular ones is what's known as the waterfall development. This method for deploying software systems in which development moves through a series of fairly well-defined steps. Larger projects, once each step is complete, it cannot be easily reversed as they flow down. Much as it would be difficult to move up a waterfall, the traditional system engineering flow allows for a requirement-driven process that leads to assured and verified functions. Big part here is literally step by step. I'm going to grab my marker. And normally you see it like as a stair, and these are the individual levels. That way this has a task complete and it moves on to the next level. And each level has specific action items that will be taking place at each level. Here we have our NIST system lifecycle. We have our initiations, and we have our development and acquisitions, our implementation and assessment, our operational and maintenance portion, and our disposal phase. So you'll notice in previous sections when we talk about these life cycles, these are general the steps. The start is, again, express what purpose, what requirements, how do we develop it, how do we require what we need, how do we develop certain portions if we need to develop it, how do we implement it, and how do we verify that what we've done is actually meeting our needs, how do we keep it operational, how do we maintain it, and lastly is our disposal. So this is part of the NIST 864 security considerations in the system development lifecycle. Although this model is depicted as a cycle, it's more accurately defined as a linear sequence that uses the waterfall development, not necessarily always repeating. Alright, so let's review the first phase, the initiation phase. During the initiation phase, it's the responsible of the individual or group for the purpose to define the requirements and the scope. This establishes the specifics of the item in question. Information to be processed, transmitted, stored, evaluated, security needs, all the projected portions of the process needs to be done at this level. Also, we need to look at strategy, research, feasibility, planning, and requirements. Feasibility could include economic feasibility, operational feasibility, organizational feasibility, technical feasibility, and social feasibility. It's not just feasibility of can it be successful, but specific portions of what's going on. The next major phase is our development and acquisition phase. During this phase, we are looking at how the system is designed, purchased, programmed, developed, and constructed. We're looking at the documentation, integration, the procedures and procurement portions, and for coding, the overall design. A lot of this is focusing on the design portion and how to acquire portions that may not necessarily be designed or redesigned in-house. For example, maybe you want to do a specific function that's already been developed, so you can acquire the rights for that code to implement within your program as opposed to having to develop it yourself. Again, it all depends on the specific circumstances of what you're developing and maybe the cost for acquiring versus the cost of you having to code it yourself. So of these 6 main categories, let's drill down a little bit further. Design. In addition to designing the operational portion of it, function and non-function requirements, how it works, how the workflow should be, things like that. It will also include to verify the quality of the work being performed in all of the appropriate phases to ensure that everything is going along correctly. Next would be the procurement or coding. The detailed design of the system being released is realized and optimized with the intent to be handed off to someone else that can be centralized and repeatable. They could also be dealing with specific functions, distribution, deployment, and that also means our quality assurance and our quality checking is happening in this area. There should be some form of approval process or sign-off process to make sure this works. Third would be the centralized build, and the build team will create a fully centralized, repeatable portion that is automated that allows for the building of that content and code that will be used for distribution and deployment, as well as verifying the quality assurance and sign-off portion of the phases and environments that is taken place in the procurement and coding section. Next would be the integration testing, and that means all functions and all portions of this will be heavily tested. All the data and technology connections are tested for specific systems moving through SDLC, upstream and downstream, and verifying user functionality, including any type of error handling, and there should be some stress tests of the code to ensure what happens when users try to break the software. The goal is to verify all appropriate connections and exchanges of the system that are needing to be interacted are actually in the final operational portion and environment, i.e., does everything work correctly and have we verified everything is good to go. Next would be the documentation, and again, both user and system documentation in these areas to ensure the complete description of the system from the user's perspective and the system documentation from the system's perspective. Lastly, is the user accept testing, or the UAT. They targeted at system functions that the end users will be able to execute while operating on the final production environment, i.e., get some test users that try to break the software. Get some test users to run through the software. See if users can accidentally find any bugs, holes, or logic flaws that might cause the software to stop functioning. Alright, after that we get into the implementation and assessment portion, and the major parts of this are installation, conversion, training, changeover, parallel running, pilot running. The implementation stage is basically moving from one platform to another. Installation of hardware or software, that will be requiring all the relevant portions for running the system to be fully operational. Conversion, that's taking the data to be converted from the old system to the new system. Could be some data cleaning as well. Conversion, again, is a huge portion of this. User training, and part of that deals with training the user on how to use the new system and get them off of the old system. Changeover, that will be taking the old system and kind of putting it to the wayside and bringing the new system online, having the new system replace the existing system, still allowing the old system to still be there, and maybe having different options. Are we doing a direct changeover, a parallel run, or a pilot run? So these are all part of the changeover strategies. A direct changeover, basically the old system is completely replaced. Very risky, but does happen. A parallel run, both systems are in place and you slowly get people migrating to the new system. Pilot run is basically the new system is running with the data from the old one and previous periods from the entire system are there. And then we're trying to check the results off of both of them. Parallel run is what I see the most often. However, organizations that don't plan it out, definitely direct changeover is where it is. Oftentimes they don't want duplicate data, so I see the direct changeover and then just dealing with the growth issues as they occur. So let's dive into these subsections. So first of all, installation of hardware or software, we already know that. That's the installation of the appropriate modules that need to be fully functional. Conversion, that's going to be cleaning up the data so that it works within the new program. The user training, people need to know how to use this new software, so user training on the new package has to be present. Again, changeover, just that. It's how we're going to get people from the old system to the new system. Direct changeover, parallel run, or pilot run. Direct changeover, again, we've already covered this and pretty much in depth. That means cutting off the old system and then going directly with the new system. We have a parallel run, that's both systems working side by side. And then we have a pilot run, which basically we take a user data and a few users, put it on the new system, and we compare and contrast how they work together. After that phase, we have our operation and maintenance. Because essentially after that phase, the program's up, the program's developed, it's working, it's in a live production, so you have to keep it operational. That includes making sure that things kept up to date. Bugs that are found are then patched and, again, kept up to date. Software or the underlying hardware is, again, managing, being corrected, monitoring and evaluating. If the requirements have to be adjusted, they need to be adjusted. And then again, maintenance, making sure that everything is maintained correctly, making sure that the software is running correctly, reviewing logs when necessary, and just overall ensuring that the program is running at an acceptable status. At the very end of all of that, disposal. When the program is done, can we get rid of it? Is the data disposable? How do we purge the data? Do we discard the system, information, hardware, software? What's the process? So that's part of what this is in that cycle. And again, that's a waterfall type model. We also have the SGP system development lifecycle. And so here we have the specification of requirements. Again, that's the design phase, requirement phase, scope of work, speed, response, capacity, size, transactional continuity, how long it's going to take, is it scalable, are there connectivity concerns, compatibility, what are the technical environments. Next would be the system design. That's the design that should include hardware and software specifications. In addition, the design phase could also be including the analysis of information lifecycle, what data needs to be there, how the data will be handled, how the data may be protected. Software acquisition, that's the objective of this phase, is to acquire robust, reliable software. Again, certain portions may be already designed, so you might have to acquire some additional code or design it yourself. After that, system build, that includes programming code, software packages that are customized, put together, should be carried out in accordance with, again, best practices, performed by individuals provided with the appropriate skills, and then inspected. And then from there, we start doing our system testing, and under development, including all of the packages, making sure that things run correctly. normally with some type of dedicated test environment or testing platform. After that, security testing again. Keep in mind, security should be out throughout all of this, but there should be separate individual security testing to ensure that all of the major requirements are kept secure, and it also gives us an area to do like vulnerability assessment, pen testing, and access control verification. Again, security should be in the other areas, but we do want to test all of that just to make sure everything is being kept and done correctly. System promotion criteria, basically rigorous criteria including security requirements, should be met before new systems are promoted to the live environment. So the security testing is done before we get back into production. And that production portion is called system promotion. Once we have verified, then we can get the install process going. Again, however we do our changeover, whether it's a side-by-side or direct cutoff or some type of pilot run, it really just depends on your environment. After that, post-implementation review, once we have the system operational, if it's a direct cutover, if it's a parallel run, we get feedback from our end users, and then we document. Part of the documentation would also include the user comments and any adjustments that need to be made. Once the documentation is done, then we can build into the system decommissioning. And that would mean the disposal should be carried out, again according to policies, but only once it is done. So the old system might be disposed at this point, new system being brought into life, or this could be the post-implementation, could be well after the installation, and the system decommissioning could be for the current system or the new system that is recently developed. And again, these are just general areas that sometimes are rinse and repeat as they go through the processes. We also have areas for DevOps, the concentration of development and operation that refers to development of applications. We call that our DevOps. DevOps focus on development operations. They've been developing an application and supporting software, and they run the software. The philosophy is that all participants in creating a product or system should collaborate from the beginning. Doesn't always happen, but that's the goal. That includes security staff, end user groups, developers, operational staff, everyone. That way we can have a product at the very end that is successful. A traditional information system development project proceeds sequentially through these stages. However, that doesn't always mean that they follow the same stages. We normally move sequentially through them, but there are methods that allow us to go back and forth. So these strategies in general are a part of the development process, system integration testing, user accepting testing, and then production. And again, these can be in different areas, and maybe not all of them are hit as heavily. It really just depends. Again, within this process, we have that waterfall development process that allows us to stagger the stages and verify each component before going on. Because once we go on, it's really difficult to go back. We have other forms of DevOps areas like our agile software, and that begins to gain favor in the last 20 years. Agile software development is essentially emphasizing teamwork, custom involvement, and most significantly the creation of smaller partial pieces of the overall total system to be tested and slowly brought in. For example, an application with 25 features, you may prototype 5 features, and then you slowly add to it to verify, as opposed to the waterfall method where you do everything and then you make it really hard to go back. With the breaking down of these partial features, it'll give you the flexibility to go back and forth. DevOps takes the philosophy a lot more in depth. It characterizes by rapid releasing, feedback loops, and embedded throughout the entire process. Basically, the rapid release allows you to go back and modify, so you might have 2 steps forward, 1 step back, but you can do this more rapidly to develop a much greater product quicker. So here's the DevOps reference architecture. And again, always continuously releasing, deploying, testing, verifying as they move through the plan, measure, dev, test, release, deploy, monitor, optimize, rinse, and repeat. And this is part of the DevOps for Dummy, also known as the Share 15 standard, that provides the overall process. DevOps also have a repetitive lifecycle in the four main areas, which we just said: plan, measure, DevOps, test, release, deploy, monitor, and optimize, which are pretty similar of other areas we've already looked at. Plan and measure, that's the activities focused on the business alignment, business processing, aligning the plan to the business. That includes development measures and metrics that are used to evaluate the software and adapt and adjust continuously so that the customer needs are always met. Second are develop and test. That area focuses on collaboration, development, continuously integration of new code, and always testing. Release and deploy. Basically, these activities provide a continual delivery pipeline that automates deployment, the test, and production of environments. Releases are also going to be managed centrally. Basically, you keep updating, fixing, releasing, deploying, and going through, and you turn through the process fairly quickly, and you monitor and optimize. As you monitor and optimize, you're verifying user experiencing and monitoring the code to ensure that everything is functioning correctly. We also have an application lifecycle management, ALM. Basically, this is an administrative and control for application development that allows us to embrace required management, system design, software development, and configuration management that allows us to integrate a little bit easier within the controlling of a software project. Here's what the modern application lifecycle looks like. It's kind of you define, you develop. That requirement would then allow us the implementation. You'd get a working software platform. You'd get it in production. You'd monitor it. That would go out to the customer. That would be the operate part. Then from there, we rinse and repeat. But part of this also allows for the DevOps workflow, same process, to allow us to work through the process and ensure things are ready to use. So the ALM may actually not be ready for use, so the implementation portion might cycle a few times before it gets to working software. DevOps will do the exact same thing, but they'll make sure that the software is ready to use before it is moved to the working software portion. So there are some pros and cons between the ALM and the DevOps workflow. Oftentimes I see the DevOps workflow probably the most common. So we need to look at incorporating the security into the SDLC. NIST 864 lists the following as benefits for integrating software security into the software development lifecycle. Basically, early on, security is built into the process, not an afterthought, not being an add-on. So secure coding from the beginning improves overall system protection and system integration with security features. One area is going to be things like the awareness of potential engineering challenges that are going to be there within the software component. Early identification, we've already discussed. Identification of shared security services, that's another big one, as we're looking for strategies to ensure security throughout the entire life cycle. Facilitation of informed executive decision making throughout the application. Again, this has to be thought through and actually managed all the way through. And for that is it's informed executive decision making. The goal here is to have data-driven decision-making tools throughout the flow of most programs. But that does mean having an executive or someone of certain level of status that okays the entire process. Documentation we've already reviewed. Organization and customer confidence within the adoption process we've already discussed. And improved system interoperability and integration that's difficult to achieve if security wasn't done from the very beginning. Again, all of this are the building blocks to ensure security is throughout every single level of the organization of this platform. The organization, the structure, the design, the implementation, the training, everything. Security from the ground up only aids in keeping the systems more agile and ensures that security is fully functional throughout the entire process. We can further go on to explain that the 864 makes use of things like major security activities. Again, number of security-related activities throughout the entire system and incorporate it into the design phase. We have the expected output. When you have A, B, C go in, D comes out. All of that can be very specifically designed for deliverables for each of the main activities. Synchronization could also be there, synchronizing feedback loops between the processes and the tasks and logs, and the verification of said content, as well as control gates. All of these are things specifically dealing with security that can be built into the overall design of a program. So we can see security at individual phases. We can see security within the initial phase. So again, as we make the decision, we initiate the project. That project should also have a security plan built into it. We can categorize the information, and then we can assess alignment with business projections, business goals, business analytics. We can adjust the privacy impact or security impact, and then we can feed that into a secure system development platform with the appropriate control gates. And again, part of this could also incorporate things like synchronization and review and process review. As we move away, we can look at our system owner. Who controls the platform? Who controls the who has the responsibility or the control of said software? Normally, if it's an organization, it's going to be a structure of who controls it, and it will probably be a department, not an individual. But in smaller mom and pop shops, a system owner could be an individual. It's anything that has the responsibility for development, procurement, integration, modification, operation, maintenance, disposal, modification. We already said maintenance, but any form of modification, or who controls access to said code to be able to make those meaningful changes. Those are going to be the ones that are classified as owners. So if we're looking through the system owner perspective, again, we can have the initiating the project security plan. So while initiating the project plan, the key security role that will be active throughout the entire SDLC should be identified. In addition, the system owner will need to identify the standards and regulations that apply to the development of the overall plan for the organization and this project. That will include things like milestones during the system development. It will also have important areas to ensure that all key stakeholders have common understanding, including security implications and considerations and requirements that the plan will be enabling. That will also include the developers to design the requirements into the overall system. The expected outcome of the activities is set to support the documented process and provide a record of the agreed upon planning decisions through everyone throughout the process. We could also categorize information system and assessment impacts. We could categorize the data using a NIST 837. We can identify the purpose to identifying the information. We could categorize the process. We could then check the results, and that should also include how they're going to be handling the information taxonomy or the catalog of informational types. We should expect the appropriate outputs and supporting rationale for the information and information security categorization, and then we should assess the business impact and assess the privacy impact within synchronization of the overall categorized activities. Essentially, we have to ensure that what we're putting into the program and any of the portions of data it's collecting are going to be aligning to our protection model, our security model, our privacy model, and we minimize risks the best that we're able to. So what does that mean exactly? So when we're looking at the categorization of information for systems and assets, or assessing those assets, there's an impact portion here. We have the ISO 27001 for Code of Practice for Information Security Controls, suggesting that very specific security requirements. Again, the key result of this process categorization is to assess the business and privacy impact, privacy and security impact that should be set forth throughout the security requirements throughout this overall process. These include the level of confidentiality required, access provisioning and authorization process, user and operator knowledge, that includes duties and responsibilities, the required protection that are necessary for all assets involved as they directly relate to confidentiality, availability, and integrity, the requirement derived from the business process, and if there's any repudiation component, logging and monitoring normally where this falls into. And lastly is a requirement mandated by other security controls such as interfaces to log and monitor for data leakage or protection or outside scope content or even just back-end access. So there are requirements for building in security for accessing data, reviewing data, and just how those systems interact with one another. So how do we ensure secure system development? Well, first of all, the system owner has to build it in from the very beginning, through the design process and through every portion of the SDLC. It needs to be in the documentation, it needs to be as a scope, it needs to be in the expectations, all of it. So, considerations for it being throughout the SDLC: secure coding, standard and process development, quality management, secure the environment, and secure code practices and repositories. These are all pretty common concepts when dealing with security through the SDLC. So source code repositories, that's going to be a repository of source code that can be reviewed, analyzed, and ensuring alignment of secure code best practices. A control gate, which we've talked about a little while ago, dealing with the initiating phase, involves determining acquisition strategies, concept for review, architecture review and alignment, financial review, risk management, vulnerability assessment, vulnerability management, and so forth. Here's the overall security and development and acquisition phase. Again, we're going to look at risk as it is based off of the system, document the appropriate security controls, design the appropriate architecture, and then conduct testing when appropriate, conduct the security control review, and then develop the appropriate documentation, and that gets piped out to a control gate. So all of this goes back to risk. So that means there needs to be some form of assessing risk for the selected controls. Because as we're building out whatever software platform you're wanting, there is going to be a conversation about how we define risk, how we refine risk, how we assess risk for all data that will be flowing through the program. So risk assessment will enable an organization to determine the risk to operations, to assets, to individuals from operation of those management systems, storage, processing, and transmission. So the risk assessment activity will look at the current knowledge of the system design, the impact assessment information from the initial phase, and then the results that are then used to supplement baseline security controls that will be identified during the initiation phase. The expected output is then refined as a risk assessment based off of the more mature model design that more accurately reflects the potential risk to the system. This will be known as weaknesses in the design, identified projected constraints, and known threats to both IT and business components. All of that's a nice, clever way is we're going to be looking at risk of data throughout the entire process, whether the data is being processed, stored, transmitted, and what controls are put in place to allow for a certain level of protection. that includes moving into the functioning testing. So as we have data, as we are looking at securing it, how do the different functions actually work together? So security testing will advertise certain mechanisms for protection under very specific operational conditions to determine a given function works as required. For example, you might have a program that expects input of 10 and an output that will double it. Well, if you keep putting in, numbers and you get the proper output, what if you put a letter in? Does it provide a proper output, or does it actually provide proper error handling? Does it yield the same result every time? And so there has to be functional testing of controls to ensure different pathways all are generating items as expected. The protection could be security, could be an error message, could be input validation, whatever the requirement is that it's needed has to be there. That leads us into our next type of testing, which is pen testing, making sure that the code is functional and making sure vulnerabilities aren't present to the best of our ability. That does mean actually having a pen tester come in and actually try to break into the software or evaluate the software to mimic a realistic attack. That way, we can identify security concerns. After that, we have our user testing, and again, that's a phase of development where we have potential users try to use the software. That way, we can ensure that the users are properly trained, and we can also test the functionality of the program by giving users a test drive through it. That way, users can actually find any of the holes or gaps or anything that we programmers didn't actually find in our first several passes. The big thing is users have the ability to find the holes that programmers never really thought about. For designing the overall architecture of the security, the goal is to have input, expected process, and what should be a quantifiable output. The security architecture should be designed to produce very specific details, and that also means incorporating very specific controls. If you access a system, you should get A, B, C. You should know what controls are going to be there, and you should be able to reproduce this and give it to a user, and then again have them be able to reproduce it. Expected outputs will include shared resources, identified common controls, verifying of expected outputs. All of those are measures that have to be there. That also then leads us to the developing a testing and documentation process. Being able to do some of this is only helpful if you can produce the required outputs. So that means being able to test the controls, verify the controls, and ensuring that they are going to be functioning. Then documenting those controls and features as they relate to the entire system. And there is a management framework for defining this correspondence in the NIST 837. Again, going back to control gates, this is all in different areas. So here we're looking at the development and acquisition phase. That's going to be the design review, performance review, functioning review, risk and assessment, risk and vulnerability, management review, and milestone review, including financial reviews. Here is our process for implementation and assessment phases. Again, create a detailed plan for verification, integrate within the appropriate security controls that were happening from the very beginning, assess these security controls, authorize the appropriate information, verify, and if actually passes, go to the appropriate gate controller. So part of this was creating a detailed plan for certification and accreditation, verification planning essentially. So that CA plan is a comprehensive assessment of the management, operations, controls for the entire system that can be verified and can be processed. So there's an accreditation process, which is an official process for actually stamping approval. If you're doing this type of program and it's being distributed through certain platforms, they actually will require some type of certification and accreditation. So these are more formalized processes for completing certain actions. So how does that look like? So there are actual plans. There's authorization officials. There could be authorized governing bodies. It really depends on what the purpose of this program is. Is it an internal? Is it an external? So keep that in mind. If we are publishing it through a third party that other people will be purchasing, again, there are authorizing officials that will verify content. The expected output of the activities is typically an agreed upon work that has been defined and verified through the requirements of said program, especially if this is a third party working on the program. Integration security with the environment or the systems. It's integration activities from the very beginning to ensure security controls are embedded and enabled throughout the entire process, and that means controlling the appropriate output and possible data leak areas to ensure all of the alignment. That will include system documentation of all controls. There is an assessment system for securing. There is part of the NIST 837. Step 4 is looking at that risk management framework and defining the system risk, system security, as well as ensuring certain privacy controls. The privacy controls are outlined in the NIST 853A, but there's still an expected output of the activity for security accreditation. And again, that's going to be assessments, vulnerabilities, plans of actions, milestones, and appropriate controls as lining up to the scope of the project and requirements of the project, ensuring that all actual measures have been in place and then verified and then validated. The objective of this assessment process is to validate the system complies with the functional and security requirements and operates within the acceptable limit of residual risk that was identified at the beginning of the process. Plan of action and milestones. When we are doing any form of plan of action, it's documentation that identifies tasks that needed to be accomplished and breaking them up into milestones or areas that you can actually achieve. So this is also going to include a metric for achievement. If you have a giant project and you break them into 5 milestones, what each milestone is going to be completed and the measurement that you're going to use to verify. The purpose of this is to assist an organization in identifying, assessing, prioritizing, and monitoring the process of a system or process that is being worked on. And that includes, hopefully, finding security weaknesses as you work through the process and then addressing them before each of the milestones. Here's an example of a contingency training. Here is part of the NIST 853. These are controls for supplementing guides for assuring certain levels of protection. Here it is for the CP3, again the 853A, contingency planning for identifying certain areas. Then we have authorizing the actual information systems. Again, authorization is known as security accreditation, granting by senior levels to verify the effectiveness of the controls by upper level of assurance and identify whatever risk that is present. Again, the authorizing official, normally an executive, ensuring that risk decisions comply with all mandates, and again, all expected output is then verified. The control gate here is system readiness test, the CNA certification review, authorization decisions, and final project status and financial review. All of this goes to the final portion of the software verification to ensure the alignment of the program and meeting all appropriate milestones and measurements. So this is going to be done through the implementation and assessment phase, which will include, again, system test readiness review to ensure the readiness of the system. So this is how it's going to be outlined in the operation and maintenance phase, we have the review of the operational readiness component, look at configuration management and controls, conducting the type of monitoring, verify, and then control gate. This allows us to ensure a certain level of performance. That also then allows us to feed into things like if there are areas identified that require modification, we might have a change control, and that is some type of system that will approach the managing of all changes to the system that will outline what the change is, how the change is going to be made, how we're going to measure the success, and a rollback plan just in case the change doesn't actually meet the new mandate. We also have a change control board, and that's a committee that will make the decisions about what changes are necessary. With that, we have ensuring configuration management and controls as part of the change management system. These configuration management controls ensure that there's a certain base level of understanding within the configuration management and controlling the modification of any said code to a platform or a system to ensure base level protection is still protected. This basically ensures that not an individual, if they do make a change, that the changes are actually thoroughly understood throughout the entire process. So if you update function A, does that function then produce an error or produce a concern in any other area? So these expected outputs after a decision of making a change are thoroughly investigated to ensure there are no gaps or newly created vulnerabilities because of the new modified or the new change that is being made. The control gates for this are, again, operational readiness, change board, and our activities and review, and then again ensuring alignment and milestones and finding the appropriate metrics to ensure alignment. And again, senior level or an executive or authorization decision making that is authorized to stamp this ready to be moving to the next stage. Here we have the security and the disposal phase. So the disposal phase is typically the last phase, but as we have completed the program, maybe it's been operational for a while, we might have a certain alignment to when the software can be disposed of, and that ensures what level of cleaning might be having to be required for said program. Maybe we have a disposal plan for said program as a way to clear or purge certain data that might have been protected. That way we can ensure sanitized media, maybe disposal of hardware and disposal of software that is properly based off of accreditation. All of that ensures information is purged correctly before the closing of a system that would then translate to a control gate that then translates to the end of the system as a whole. System development management will identify and solicit demands for the development, the strategy outline, the project scope, all of that. So there are international foundations for defining the functions of management of systems from the entire process. Strategy, research, delivery, requirements, scope, build, design, control, deliver, operate, maintain, all are key areas for system deployment management. That includes things like ownership, inventory, terminology, metrics, transparency, standards, and best practices. The environment is going to be the particular environment, both hardware and software configuration, that the programming environment is going to run. The development environment might also include having to conduct research, developer workspace, the centralized build, integration testing, user testing, quality assurance, then getting that out into production. Other system development principles for security requirements are broken down into two main categories: security of the environment and the security of the enterprise that will house the program within the overall environment, internal and external to the organization. All of these all cover the environment protection, the asset protection, both inside and outside, the roles and responsibilities of security, the roles and responsibilities for data and information protection, security and any requirements, reporting requirements for possible data breaches, and so forth. As outlined by international guidelines for IFIT 09. Here we have quality assurance, ensuring that there are a myriad of programs that will align for verification of quality of all components being met throughout the SDLC, best practices for management and lifecycle review. And that is it for this chapter. We covered a large quantity of SDLC and DevOps and how each key category builds upon itself. We also looked at concepts for functioning testing, an overview of best practices, and SDLC, looking at NIST different models. So that is the end of this chapter. If you have any questions or concerns, please let me know. We do some of this. It is critical that we ensure that we're answering your questions. Don't just listen and don't try to apply. Listen, try to apply what we've been discussing, and when possible, if you're not understanding something, say something.